Hi there, and welcome back to Luke Explains a Mathematical Concept because literally no one understands it. I'm your host, Luke Mejia, and today we're going to be graphing tangent and cotangent functions. All right, so let's go back to basics first. So, in order to understand not only what we have to do, I'm going to explain why we are doing what we're doing, okay? So, let's go back to the beginning, right, with the unit circle and all of that stuff. What you have to understand is that tangent equals sine over cosine, right? Tangent equals sine over cosine. And that means cotangent, which is just kind of the opposite, right? Cotangent, what does that equal? Cosine over sine. Cool. All right. Now, if we have our unit circle here, I don't know if there's any way to, that doesn't look great, but it's going to be the best we get. So if we have our unit circle here, right, then we have this point right here. Let's, that is the point 1, 0, right? That's 1, 0. And this point up here is 0, 1. Okay. And the angle of this line right here, that's 0 degrees or 0 pi. And the angle of this line right here, right, that's going to be obviously 90 degrees or pi over 2 is what we call that angle, right? Okay, so at 0 degrees, our cosine is going to be root 4 over 2, which is 1, and our sine is going to be 0. So that means that this right here is cosine, and this right here is sine, right? Cool. And then our cosine and sine over here, cosine is 0, and sine is 1, right? All right. Now, what is our tangent going to be then? So we know tangent is going to be sine over cosine. So right here, it's going to be 0 over 1, which is just 0. And then up here, it's going to be at pi over 2. Tangent is going to be 1 over 0. What happens when you divide by 0? Well, that's impossible, right? So our answer is undefined. That really can't happen. You can't divide by 0. Undefined, right? So tangent of pi over 2 or 90 degrees, undefined. Okay, and cotangent, that means cotangent of 0 degrees. Cotangent is cosine over sine. So cotangent at 0 equals undefined, right? Because that would be 1 over 0, which is undefined as well. That's our sign for undefined. Fine, undefined, my bad. Okay, so now we can go on to our first example. So our parent function, which is just like our regular function, this is basically how we write it. So y equals a tangent x, or b, bx minus c plus d, okay? So our first example, we have y equals tangent 2x minus pi over 4 minus 2. Okay, so how are we going to graph this? Our goal is to be able to graph this, right? So first, let's identify our b value. So b equals 2, right? Okay, cool. Now, our b value, that's important because to find our period, which is basically how often does it repeat, that's our period. Our period is equal to pi over the absolute value of b. So, which equals pi over 2 in this case. Okay, so that's our period, is pi over 2. Now, how do we find our vertical asymptotes? That's our next step. So vertical asymptote 1 equals, how do we find that? So what is a vertical asymptote? If you remember from algebra 1, when we have the exponential graph, it kind of looks like this, and there's a line that goes up like that, right? And so that line is never going to quite reach our horizontal asymptote. This is horizontal asymptote. So it's the line that we never quite reach. So our vertical asymptote is looking like this, and we're never quite going to reach that line in our tangent function, right? So why aren't we going to reach that line? There must be a reason, right? It's because it's impossible to reach that line. Now, where is our tangent impossible? Well, we know if we go back, tangent of pi over 2, that's impossible. That's never going to happen, right? So if we set this, all of that inside of the parentheses equal to pi over 2, that's like saying tangent of pi over 2, because if this equals pi over 2, that's tangent pi over 2. Tangent pi over 2, impossible. That's our vertical asymptote. It's impossible, will never happen. So we set 2x minus pi over 4 equal to pi over 2, because that's where it would be impossible at. And we're gonna add pi over 4, 2x equals, that's 3 pi over 4, x divided by 2, 3 pi over 8. That's our vertical asymptote, number 1. So here's our vertical asymptote. Right here, we'll call it 3 pi over 8. And we'll draw a little dashed line at our vertical asymptote. Okay, now we need to find a few more so that we have more than just that. Because, yeah, so let's add our period or take away our period, right? Because that's every time it repeats. Our period is pi over 2. So if we add that, then we get 7 pi over 8. We have to add our period. And now we could take away our period, and we're going to end at negative pi over 8, I believe. Yep, that sounds right. Now we can draw our little dashed lines on these little sections. Okay, now what does our graph gonna look like? So if you don't know what a tangent graph looks like, it kind of looks like that, right? And there would be arrows, right? And so there's a point right there where it's gonna go from going like upwards, and it's gonna curve or going downwards, and then it's gonna curve and go upwards, right? So right here we're going downwards, and now we're going upwards. So that point, we're just gonna call it the midpoint, okay? Or maybe like kind of like the vertex, right? So that midpoint right there, let's erase this. That midpoint is what our d value affects. So our d value is going to say that we're going down to, right? That's what our d value means in this case. So d equals 2. So we're going to go down 2 with that midpoint. So let's go down 1, 2. Here's negative 2. And we're going to plot it in between our vertical asymptotes, right? So here we plot it. And we're going to go up here and down here. And then we'll plot it again over here. We'll repeat that. And down here. And that is what our graph should look like, ladies and gentlemen. All right. Now let's go and do cotangent. So cotangent is very, very similar. Y equals cotangent 2x minus pi over 4. Here's our cotangent example, minus 2. Okay, so cotangent is very similar, but it's kind of like the opposite, right? So our graph is actually going to go the other way. It's going to go from high to low. Okay, also there's a few other things. So first we have our b value equals 2, right? And our period still is pi over the absolute value of 2, or absolute value of b, which is just pi over 2, right? So now we have to find our vertical asymptotes. So how are we going to find those? So where will cotangent of what is never going to ever happen, right? Where is it going to be impossible to happen? That's what we're trying to figure out. Well, if we go way back to our unit circle back here, we said that cotangent of 0 at 0 degrees, that's impossible. That's never going to happen because cotangent of 0, undefined. So, sorry. So the cotangent of 0 is undefined. And that means if we can have cotangent and set everything inside of those parentheses equal to 0, that's impossible. That's undefined. That will never happen. So we're going to take that, 2x minus pi over 4. We're going to equal it to 0. We'll add pi over 4. We get 2x equals pi over 4. And then x equals pi over 8. That is our first vertical asymptote. Here we go. That's pi over 8. And that's our vertical asymptote 1. And now we can add our period and take away our period to find our other vertical asymptotes. What happens when we take away? That's going to be negative 3 pi over 8, and that's going to be 5 pi over 8. And all right, and then remember, since it's cotangent, instead of going from low to high, we're going to go high to low. So, but of course, also we need to find our midpoint, right, or our little vertex, and that's going to be down 1, 2. and here's -2. And we're going to plot it directly in between our two vertical asymptotes. And here's our point. And we're going from high to low. High to low. All right. And you can draw your graph much more pretty than mine. This is all just for demonstration purposes only. All right. And that right there, folks, is what our cotangent graph is going to look like. I hope this helped. Good luck.